Nazia Hossain. I'm doing Master of Engineering under Faculty of Integrated Technology in UBD, Universiti Brunei Darussalam. I would like to thank my co-author, Labiba Mahmoud, and International Islamic University Malaysia in Malaysia. They funded us, the project. Today I'm going to present introducing water quality assessment of Taman Tasik Medan Idaman based on inorganic solid. Actually, Taman Tasik Medan Idaman, this is a Malaysian lake in Selangor district. Most of you know about Kuala Lumpur, so the lake in Kuala Lumpur. Here is the content of my presentation: introduction, research hypothesis, significance, research aim and objectives, research methodology, test result and discussion, conclusion and recommendation, future work. So water is another form of life, we can say. In general view, it's a part of parcel of human life. We cannot live without water. It's the habitat of several species. Basic of all drinks and beverages, main course of human hygiene. Chemically, it's the mixture of hydrogen and oxygen, universal solvent, polar molecule, adhesive, cohesive, and great for human health. There's a National Geographic Society statistics. They mention among the whole Earth, 0.007% water we can really use. This is accessible to us for feed and fuel purpose to 6.8 billion people worldwide. Now we see in a small view in Southeast Asia, like Malaysia, Brunei, Singapore, these areas, they use mostly surface water. The groundwater is really only 3%, so 97% water used in Malaysia comes from surface water, and 60% for domestic use, 35% for industrial purpose, and 5% for agricultural purpose. So surface water is the main source in Malaysia, and recently there's water scarcity, big water stress in Malaysia. Actually, it's from the last decade, it's happening around Malaysia, especially in summer season. So Malaysian water sector, they are looking for alternative water resources. See here the water stress expected by 2020. So here's the Selangor district. This is the biggest district in Malaysia, and in summer season, this district, many places faces water scarcity problem, especially in Gombak area. So the river, the lake, we have experimented the lake water. It's in Selangor area actually. This is the lake, Taman Tasik Medan Idaman. It's the evening view as we collected the sample at evening. So we get the evening view of the lake. Research hypothesis, we got the water sample from the lake and we bring it to experimental laboratory, and then we checked total suspended solid. It's mostly salts what are suspended in the water, total dissolved solid, volatile suspended solid, total phosphorus, total nitrogen, copper and zinc. Inorganic solid, actually it's why we did this, because inorganic solid causes harmful effect for human health, and it's also lethal to aquatic species and plant growth, and it causes biofouling on water piping and feedings. The research was significant as Malaysian water sector is looking for alternative water resources for summer season especially. So actually many experimentations are going on in Malaysia on lake water. Our research aim was to determine THS, TTS, VSS, TP, TN, CU and Zinc. And the objective to measure the lake water quality, classify the water according to interim national water quality standard Malaysia, and to identify some purification process for further usage. TSS and VSS, they are actually the series experimentations. TSS is total suspended solid, but also include VSS, volatile suspended solid. Actually, volatile suspended solid, they are burnable, but still under suspended solid. And TDS, total dissolved solid, it's more on ions and salts. TNN, TP, Cu and zinc, they are the nutrients for microbes, so they are the reason water can be polluted for. We use gravimetric method for TSS and VSS, TDS meter for TDS, and atomic absorption spectroscopy for TNN, TN, TP, copper and zinc. Here's the TDS meter. Actually, this is like automatic system. So we just got the sample, we put the electrode tip inside the sample, switch on the machine, and we got the amount of TDS. This is TSS and VSS method in series. So we used this one, glass fiber vacuum pump and filter paper to experiment the TSS. We used oven to find out TSS and desiccator to cool down and moisture inside the TSS. Every time we use analytical balance to measure the weight of filter paper and filter paper with TSS, aluminum dish and muffle furnace. You can see the calculation here. Here, that we use this calculation to use TSS and VSS. And this is how we checked TN, TP, Cu and zinc. We use atomic absorption spectroscopy. This is also the so this is also automatic machine setup. We add the water sample here. This is schematic diagram. We add water solution here and put the machine probe with this, and this is the complex method. Actually, we didn't need to run this thing, it's automatic. So we just got the data from data processor. We use different reagents for each solids. So you can see the reagents for each compound. And here are the results. TSS, it gives 60 milligram per liter. It's water class 3. Water class 3 is not actually for domestic use or for drinking purpose. I will show the purposes in next slide. VSS, 720 milligram per liter. TDS, 165.9 milligram per liter. TNN and TP was 0, so that means no nitrogen and phosphorus in the water. Copper and zinc was 0.02 milligram per liter, 1.9 milligram per liter respectively. They are under class 2A or class 2B water. Here is the classification. Interim National Water Quality Standard Malaysia. So this is TDS, it's under class 1 water. Class 1 water actually we can drink. The water we drink is class 1 water. And 2A and 2B water, copper and zinc under this. They are somehow okay to drink, but not very good for long-term consumption. And TSS, suspended solid, is too much, 150 milligram per liter. Here you can see the usage for each class of water. So TDS, TSS, TN and TP, they are under class 1. Copper and zinc under class 2A or 2B, TSS under class 3. So the TSS needs extensive treatment to purification. Here is our targeted solid level. So we need these purification processes we haven't done, it's our suggestion. So we suggested vacuum filtration for lowering down TDS, TSS and VSS, and adsorption process for copper and zinc. We choose absorption process as its efficiency is 90%. Inorganic solid like copper, zinc, lead, iron, manganese, and odor and color removal up to 85% to 90%. This process is like the filter you use at home, so no energy really consumption for this, and it's inexpensive and natural driven process. Vacuum filtration, yes, this process needs some consumption, but it's like power consumption, but it's really effective to lower down the TDS, TSS, and VSS, and it's able to remove microparticles 20 to 100 micrometer. Throughout this process required energy, but it's very effective for separating solids from water and decolorizing the carbon. So now we came to end. The current lake water can be used for irrigation, animal husbandry, or non-sensitive aquatic life only. But for domestic use and drinking purpose, we cannot use it. That's why we need to purify the water in further if when I use this water. So our future plan for this work of water quality, determination of overall water quality and designing comprehensive integrated purification system, projection for scale-up scheme, and optimization of purification system through inclusive techno-economic analysis and life cycle assessment. Since the lake is in the residential area, so environmental effect, taking environmental effect is the first step we should do in the future. Thank you for listening. If you have any questions.
Thank you very much. Any questions? You can also ask a question after the next presentation because Nazia is going to present again now. Okay. So with that, we come maybe straight away to the next presentation.
Yes, it will be good.
And it's going to be also again on the Taman Tasik Medan Idaman.
Yes, same way. Hi everybody. It's the continuation of the same process. We have to see the next 20 minutes again. The project name, Investigation of Physio-chemical Characteristics of Taman Tasik Medan Idaman Water. Malaysia is the same lake water. We have run some other factors, organic factors mainly. The contents are similar like the before. The introduction, the problem statement, everything was same like before, so I can skip this. This is interesting, this map you can see, it's surrounded with the residential area and corporate area. And the lake area is quite big. So that's why we ran the experimentation on this lake water. So it will have some application in future, we hoped. The lake is mainly for purification and recreation, but as in summer, Malaysia face water scarcity. That's why we keep it in option for further usage. Research hypothesis: we take the water sample, we bring the water sample in the laboratory, and we checked pH, DO, dissolved oxygen, chemical oxygen demand, COD, biological oxygen demand, BOD, and turbidity. So now I want to explain what's DO. It's dissolved oxygen. When you usually buy water, sometimes you might find it's a bit expensive than other water, and you check the the water outside, and you can find it oxygenated water. It's like they blended oxygen in the water to make it more healthy for human body. So dissolved oxygen is the most important part for the water. So, and COD and BOD is just the opposite of dissolved oxygen. COD is chemical oxygen demand. This chemical oxygen demand actually the organic and some inorganic ions also. like the oxygen needed to decompose those organic and inorganic ions. BOD is only for organic matters like dead plants in the water, sewage and food waste, those things. Turbidity is the physical characteristics. Turbidity causes the water cloudy, like more of silica, sand, those things makes the turbidity high. The aim of this project was to determine pH, DO, COD, BOD and turbidity. The research objective was to measure the lake water quality, to classify the water quality according to Interim National Water Quality Standard Malaysia, and to identify the water purification purposes for potability. To find out pH, we use pH meter. For DO, DO meter, COD, closed reflux method, we use COD reactor. And for BOD, 5 days test method. Actually, it's called also BOD 5. So, like 5 days test of dissolved oxygen, and how much the organic matter needed dissolved oxygen. BOD is average for those calculations. Turbidity, we use turbid meter to find out the turbidity. Here I show the all machines to check the water quality parameters: pH meter, GO, turbid meter, COD reactor, and incubator. That's our experimental result. pH 6.79. The water neutral pH is 7. Actually, the purified water carries around 7. Dissolved oxygen 18.6. COD 82 mg per liter, BOD 43 mg per liter, and turbidity 9.4 NTU. Here the water classified according to the Interim National Water Quality Standard Malaysia. So the pH shows class 1. The range is 6.5 to 8.5. So our water is almost 7. So it seems like the pH is very good for the water. GO is 7. Our DO is quite higher, 18.6. That means dissolved oxygen is really high in this water, and what is very good sign for this water quality. And COD is less than 182 mg per liter, and BOD is 43 mg per liter. So they are under 4, class 4 and class 5. That means the water was quite highly polluted. Turbidity was less than 50, so the water also was cloudy. Again, I show the usages of the water. So pH and DO, they are in safe zone. Turbidity in under 2A or 2B, but COD and BOD, they are in red zone. So we really need to improve this COD and BOD if you want to use this water in further. So this water needs extensive treatment to improve COD and BOD. Let's see our suggested purification process. Advanced oxidation process. Advanced oxidation process contains 3 states: ozonation, hydrogen peroxide, and UV. So this whole process needed to improve BOD and COD. Here you can see the view clearly. It's our water is like unpure water, and we use ozone treatment to destroy bacteria and pathogens. Hydrogen peroxide actually reacts with exposure to UV light, and it breaks down trace compounds. And around flocculation, it's the traditional method. Even some areas people use this method when they have flood and they don't have enough pure water, right? They put alum in the water to settle down the impurities. Here is the large scale ozonization, and here is the personal ozonator. We showed actually the small scale because it's lake water, so if in case people are in trouble for emergency usage, they can use this way. This is larger scale UV irradiation system, and this is for personal and emergency use. purification system in large scale, and this is for personal or emergency use. As I mentioned, alarm population is traditional method, and for very long time people are using this method to purify the water, and the efficiency is up to 90% in this process. Here is the large scale, and here is the alarm. You can see. So we can put the water, and after a few hours the water will be purified. So we almost in the end now. The lake water is unsuitable for direct consumption or other domestic usage. Extensive treatment required for the this lake water, and for future work we need to check seasonal changes effect. So like Malaysia has the rainfall almost like 8 months. So we need to check that does this rainfall affect COD and BOD and also dissolved oxygen. And designing and optimizing a cost-effective purification system what would allow in situ purification for emergency usage. Thank you for listening. If you have any questions, you can ask me now.
Thank you very much. One question, yes.
Thank you very much for your informative presentation. Actually, I just want to say a simple question. When we will tell that this lake water or drinking water is quality water, you have given a table.
Yes. Yes.
Classify one.
Yes,
So
classify.
the number one is this is the
Drinking purpose. You can
quality
drink.
water, is it?
Number one water is the purified water we use. We use this
So
water.
when we
This is
will
number
tell
one water.
So this is number one.
Yes, this is number one.
This is the quality water.
Yes, this is the quality water. Thank you for the question.
Nazia, I think that there's a little bit difference in the pH values of your first presentation and the second one. I think that was in between 5 something, while here in the second presentation that it's near to 7. Am I
On
right?
the first presentation, I didn't use any pH. That one just inorganic solid. I think you saw pH in the Brunei water. That one was near to 5.
I think so.
Yeah. But this pH is the organic one I used for the second presentation. Thank you, sir.
I have a question. Is it possible to purify water using activated carbon?
Yes, of course it is. I want to show you the slide. Activated carbon, I think the first one. Actually, in the first one I showed activated carbon.
Yes.
And it's very good for the water to purify. The efficiency is until 90%.
Okay.
And you can use also in small scale, like in small filter, they have also a layer of activated carbon to purify the water.
Okay. That's interesting. Thank you.
Thank you. Anything?
Just one question for me.
Yes,
The lake is a natural lake or is it
It's not natural, it's actually human-made lake. But it's almost 20 years ago it has been done. So now people even can use reservoir if they like to.
Nazia, I have one question. If we use activated carbon in industrial sector, we can use it, right, to purify water?
Yes, in industrial sector also you can use, but the techno-economic analysis is needed for that. Because industrial purpose is huge, so at the beginning you have to invest quite high.
Thank you.
Alright. Any more question?
Thank you very much.
Okay, if in case you don't